Okay, so in this video, we'll talk about the ground state term symbol as predicted by the Hund's rule. So that's the minimum energy. So this is part of a series of lectures on many electron atoms for the chemistry department at the University of Lagos. We've already talked about term symbol. Term symbol represented by multiplicity as the pre-superscript. Then the letter symbol for L, that's the total orbital angular momentum. And then as the post subscript, the total angular momentum quantum number. And then we know that for electrons for two electrons in a p orbital, we can count about these terms for the states to give the appropriate right quantum number. And for an equivalent electron, not all these terms are allowed. So the only ones allowed are the singlet D term, triplet, and singlet S term. Okay, so if we obtain these terms, which is the most stable, this is determined by Hund's rule. According to Hund's rule, there are just three of them. The lowest is always the one with the maximum multiplicity. So highest S. After the maximum multiplicity, then the next one is the largest L. So if you have several with highest S, then you consider highest L. If they have the same value, if the terms have the same value of L and S, then we consider whether it's coming from a subshell that is half-filled or a subshell that is more than half-filled, less than half-filled, or that is more than half-filled. Remember, we only consider unpaired electrons when we are considering term symbol. So, the half-filled subshell, now if it's half-filled, because we said that less than half-filled and more than half-filled, the half-filled subshell always has the term with the largest multiplicity and is always an S term. So if you have an half-filled, so there is really no issue. Okay, so let's look at an example. The terms that arise from titanium are F3, 1D, 3P, 1G, and 1S. F3, 1G, 1D, 3P, and 1S. So which of these has the least energy? First, we consider maximum multiplicity. So this is 3, 1, 1, 3, 1. So we have two that have a multiplicity of 3. So that means the lowest energy is either 3F or 3P. So then we now look at the largest L value. So L for S is 0, L for P is 1, L for D is 2, L for G is 3, L for F is 4. So this is 4, this is 1. So the largest L is 3F. If we now want to include J, 3F, L is 4, we just deduce that, and S is 1. So J can take values of 5, 4, 3. So the term symbols are 3F5, 3F4, and 3F3. Now if the term have the same L and S, then for a subshell that is less than half, the term with the smallest value of L is the most stable. So what is the configuration of titanium? The electronic configuration of titanium is argon, which is a closed shell. A closed shell is 1s0, singlet state. 3d2, 4s2. So these terms arise from 3d2 because 4s is also a closed subshell. So which gives one singlet s0 term. So this is 3d2. The d orbital can have a maximum of 10 electrons. So half-filled means that So D5. So D2 is less than 5, so it is less than half filled. So if it's less than half filled, the term with the smallest value of j is the most stable. So the most stable is 3f3. So that's it for the Hund's rule.